This lesson is going to be about intervals. Now, in order to do intervals, you'll need to have a very good grasp of scales. So hopefully, by now, major scales especially are not a problem for you. If you're still having some problems with major scales, please go back and review them before you start learning about intervals. Intervals come in many different varieties, and we're going to start first just with perfect intervals. Now, when we call something perfect, that sounds like a judgment statement, but actually the name perfect intervals doesn't mean they're better than the other intervals. It just means perfect intervals are not major or minor. Be sure to remember that. If something's perfect, it could never be major or minor. So the intervals I'm about to tell you about that are the perfect intervals, you will never find one that's major or minor. Now, intervals have two different types of names. I've been so far just talking about the type of interval. We can also talk about a generic interval. When you look at the name of an interval, it will always have two parts to it. Right there you can see a letter and a number. This P stands for perfect. The 5 stands for a fifth. So whenever you learn about an interval, or when you're talking about an interval, we talk about the type and then the numeric interval. On the board here, you can see the most basic interval. This right here is called a perfect unison. And if I were to label it, I would label it a P1. So it's a perfect unison or a P1. Now, you might think it's strange that we would label something like this, but you can think of an interval of a unison. For example, if you and your friend go to sing a note and you sing the exact same note, that would be a perfect unison. So two people singing or playing, or however many people singing or playing the same note, they're performing a perfect unison. And we write it this way, with the notes right next to each other. So that doesn't necessarily mean they're played one after the other. Usually they're actually a little closer together like this. It just means they're a unison. Two people performing the same pitch. Now, when we talk about the perfect intervals, think about them is to think about the overtone series. So, when you have a string and you hear a pitch, the pitch you hear the most loudly, that is the fundamental. And I will play a note for you just so you can see what I mean. Now, when you hear that pitch, you hear one note mainly, and if I asked you to sing it, you probably could. However, if you listen really closely, that note is also made up of other notes that are created in direct relation to the original note. So the first note we call the fundamental. And in this case, we'll say this C is our fundamental. If you listen closely, now I'll play the first overtone, and then I'll play that note again, and I want you to try to see if you can hear the first overtone within the pitch that I play for you. So here's the first overtone. Listen to that. Now I'm going to play the fundamental again and see if you can hear this note within that fundamental. Can you hear it? I'm only playing the one note, but faintly you should be able to hear this note as well. Now I'm actually playing this on an electronic keyboard, but the interesting thing is that the relationship between the fundamental and the overtones is a large part of what we hear that allows us to recognize the sound of different instruments. And so even though this instrument isn't really creating those kinds of overtones through the use of vibrations on a string like you would think of in a piano, it does still create overtones because that's how they make it sound like a piano, by the relationship between the different overtones, which ones are louder, which ones are softer, exactly how in tune they are. That's what gives us the distinctive sound of different instruments. Unpitched instruments like percussion, those overtones are not in tune to the fundamental, and that's why we can't identify a pitch. For example, when you hear a snare drum, those overtones are not in a clear mathematical relationship to the fundamental. So that's why you don't hear a distinct pitch. Now in this case, we measure frequencies in hertz, or vibrations per second. And if your fundamental, this is not the case for this, but we'll just use it as an example. If your fundamental was 100 hertz, then your first overtone would be 200 hertz. That would be the frequency of the first overtone. And your second overtone would be 300 hertz. And your third overtone would be 400 hertz. And they're in a direct mathematical relationship. And that allows you to hear that pitch, and it sounds very in tune. Like I said though, with a percussion instrument, you might have 100 as your fundamental and 218 as your first overtone and 257 as your third overtone. And that's what makes those sounds unpitched. But we're talking about pitched sounds. So if this is our fundamental, our first overtone is 1 octave above our fundamental. And an octave is a perfect interval. We label it P8. Now let's talk about the second overtone. Here's your fundamental again. And this is our first overtone. This is our second overtone. Listen to that closely. Okay, now when I play this note, see if you can hear this within it. Hopefully you can very slightly hear this second overtone mixed in within the sound of the fundamental. The second overtone is also a perfect interval. In this case, the space between the first and second overtone is a perfect fifth. And we'll get to why the numbers in a moment. Finally, we'll talk about the third overtone. Listen again. This was my fundamental, my first overtone, my second overtone. This is my third overtone. Now listen closely to my fundamental and see if you can hear this pitch in it. Maybe not as much as the first and second overtones. We won't continue on to the next overtone, but the important thing, or at least the interesting thing, is that when you're learning about perfect intervals, one way to think about why they're perfect is that they actually are in a direct relationship in terms of acoustics to each other.